All right, welcome to a new session on low carbon cement and concrete. My name is Surekha Sumanasuriya. I'm the technical director for NEU. Dean Frank was another moderator, new executive director, but unfortunately he won't be able to make it to the session today. So I'll be moderating the session. Again, as I mentioned before, if you have any questions, please reach out to us. Okay, the learning objectives for today's presentation report on the current and upcoming low carbon concrete technologies and materials. I can't really read and can read the screen too. Anyway, explain NEU's technology validation or verification program, discuss codes and standards on low carbon cement and concrete materials, and recognize ACI code advocacy efforts toward the adoption of low carbon cement and concrete. As I mentioned before, this session has been approved by AIA and ICC for 2 PDAs. All right, so again, here are the learning objectives, and we have great speakers and topics. I'm not going to read all of them. I'll introduce them when it's time. And I'm going to go through a very brief introduction of NEU. Again, I'm Surekha Sumanasuriya. I'm the technical director for NEU. I have been working in the ACI engineering department for about 5 years, and I joined NEU last year. I think that's all about me. All right, the NEU why focus on carbon? I think the answer is clear to most of you. When it comes to sustainability, that's what we all talk about these days. There's a lot more to sustainability than global warming, because we need to address environmental, social, and economic factors. However, or at the same time, concrete plays a great role in sustainability, right? It's resilient, thermal mass, durability, lot more benefits. However, global warming is affecting everyone in the planet. And cement and concrete industry, probably you have heard it a million times now, contributes to about 8% of global carbon dioxide emission. The good news is the industry is in an excellent position to improve upon this area. There are many ways to improve this area, and we can measure the carbon dioxide emissions in cement and concrete production. So when we can measure something, there is a room for improvement. So we are in an excellent position to make an improvement, and NEU is there to support that goal. Again, there are many roadmaps through various construction sectors, organizations, and global regions. And this is just an example from GCCA. Again, just an example, the ways to reduce carbon emissions towards net zero goal in 2050. As you see, there are many options, starting with carbon capture, utilization, and storage. We can reduce up to 36%. I'm not going to go through each of these items. Some of our speakers are going to talk about these. Again, this is just an example. But as professionals, what should we do? We hear a lot of information. It's truly overwhelming, right? We hear from industry, we hear from legislators, we hear a lot of information how to reduce carbon dioxide emissions in this industry. And this is a broad industry. There are a lot of moving parts, design, construction, materials, and many more. So we need to understand this. At the same time, various professional knowledge levels from both the supply side and the demand side, right? And end users may know very little. So we need to address those issues, and we need to educate them. At the same time, there are different new materials and technologies come to the market. So there is a clearly need for accelerated adoption of these new materials and technologies. So ACI is always advancing, and ACI saw the need to address these issues. And as you may already know, ACI has always influenced the cultural changes in this industry. Right? It has been there for more than 100 years. And ACI provides great products, opportunities, benefits, and it's a non-trade organization. And some of these you already know I have listed here. So ACI saw the need and wanted to address these carbon emissions in the industry. That's why the board of directors came up with the NEU Center, an ACI Center of Excellence for Carbon Neutral Concrete, to address especially this part of the puzzle. All right, let's quickly look at our vision, the center envisions a concrete industry where all stakeholders have access to technologies and the knowledge needed to effectively and safely produce and place carbon neutral concrete and concrete products in the built environment. If you look at each of these words, they are important. Okay? Effectively and safely produce carbon neutral concrete. So with that, the mission is to drive education, awareness, and adoption of the use of carbon neutral concrete materials and technologies. When we say adoption, we actually mean by appropriate adoption of these technologies. Because we hear a lot, we want to bring latest, greatest materials and technologies to the industry. At the same time, we want to stop greenwashing. Okay? So that's in our mission. With that, NEU has several core functions. Some of them are listed here. Materials and Technology Validation and Verification Program. Mahmoud is going to talk about it in a few minutes. And Technology Transfer and Acceleration or Implementation, another vital piece. Advocacy and Technical Support. We have Steve here going to talk about those. ACI Committee Assistance, Training and Professional Development, and International and Student Outreach. So if you look at this a little bit closely, again, I'm not going to go through the whole list. I'm trying to save time here. Technology transfer is a vital piece of this work, of course. Towards that, we are putting together several different things, including webinars, case studies, low carbon concrete guides, frequently asked questions. And the nice thing is ACI is a recognized leader in this area. Okay, so we can use these resources to disseminate information. So we use these resources and try to get you with the right information. So if you go to the new website, if you go to resources, let me see whether I can show some of this. Anyway, oops. Yeah, please visit the website. Under resources, you can find case studies, frequently asked questions, and also several CI articles, ACI University webinars on low carbon cement and concrete production and placement. Okay, and this website, we keep adding stuff, and the resource page keeps growing, so you can go and look at what's available. Another core function is advocacy and technical support. ACI has long recognized that advocacy is important, and we have 2 advocacy engineers in this room at this point, and NEU will advocate for the use of sound technical information and application of existing knowledge. Again, as you see, there are many things we can do within NEU, and one of the recent effort within ACI and NEU's participation is the ACI 323 low carbon concrete code. So we provide support to get these things out. And in our very recent effort, we had a new summit on accelerating carbon neutral concrete materials and technologies. We met with several federal organizations, including NIST, FHWA, DOE, EPA, and several other key players with our members. And we had a really good conversations, and it was very clear that we need to collaborate with each other, because everybody is discussing this, so it's important to collaborate with right people, right organizations, right? At the same time, it came out, it's very clear that we need to make the awareness and adoption of these new technologies. So we are going to continuously work with them how to make the awareness and adoption. All right, little bit about our membership. It's open to anyone at the corporate level. Anybody can join. As you see, we have several different type of members join NEU over the last year. Of course, our founding member is the ACI, and we have sustaining members, Meta and Breakthrough Energy. We have a supporting member, Baker Concrete Construction, and at this point we have 12 affiliate members, and we are very thankful to our members, because without their support we can move forward. So thank you, and appreciate their support. I see some of you are in this room. And the membership is growing. We are very excited about that. All right. We also have another membership category called Allied Organization. So what we do here is we work with organizations that the mission align with our mission. Okay. Right now, we have these members as allied organization. Again, we are working with many other such organizations to work together with us. All right, meet our team. I'm here. All of us are here except Kelly Dudley. Say hi. Contact us if you have any questions. And also, you can get the NEU news through NEU Smart Brief, newsletter, webinars, ACI convention, and summits. And last year, some of you remember, we have a standing only room for our specialty day. We are trying to bring it back again. And thank you again for joining today. This is the only time slot we got. I know it's Wednesday afternoon, not the favorite time, but I'm so thankful that you are still here. Okay? So thank you. And if you have any questions, please reach out to us. And you can follow us through social media, LinkedIn, but of course, reach to us through these emails. All right, with that, I'm going to stop, and I'm going to invite Mahmoud to talk about NEU validation program. All right, until he's ready, Mahmoud Tekel, PhD, FSCI, is currently working at ACI as a certification and conformity assessment engineer. Formerly, he was a senior engineer at ICC. He received his MS from Southern Illinois University and his PhD from Missouri S&T University, where he also worked as a postdoctoral researcher. His research interests include building codes and alternative construction materials, fiber reinforcement, polymer and fiber reinforcement, reinforced cementitious matrix, strengthening of concrete structures, and fiber reinforced concrete, of course, FRC. He's a licensed professional civil engineer in California and several other states. And he's a NEU validation and verification director. Thank you, Mahmoud, for joining us.
Thank you very much. I have very limited amount of time to introduce the validation and verification program, and I have a good number of slides to cover. So Sureka already introduced me, and I'm gonna, Sureka, our technical director, already talked about the issues with the climate change, which is a part of our life nowadays. And just to ease the effects of this climate change or delay the effects of the climate change, there are a lot of incentives in the market. Some of them are from private sector. Some of them are from government institutes. I put Microsoft as an example, but there are many companies trying to deal with this climate change issue. And for example, state of California, it has a very, very ambitious goal. They want net zero greenhouse gas emissions by 2045 and at least 40% reduction by 2035. And just to, because of these incentives, companies are making claims to position themselves and their products as possible solutions for reducing carbon emissions. So what is the issue with making a claim? Everybody's making a claim, right? What could go wrong with a claim? So let me give you an example. Let's assume I have $5 million, and there's this alternative cement company who claims that they already comply with California's 2035 goal. And so if I invest my $5 million for this company, based on their claim, because they already comply with California 10 years in advance, I'll be ahead of everybody else. You know, what's the question I should be asking first? The question, if, you know, the issue with the claim is it's going to be a part of my decision-making process. I'll be making my decision based on that claim for investing my money. And, of course, I will be asking these questions. Is it accurate? Is your claim accurate? Is your claim reliable? In a sense, I am looking for an assurance. So that was the reason for generating validation and verification program. And the main goal is to secure the trust of the customers, and by using reliable methods. And the goal is to separate what is plausible and what is an insubstantial marketing promise. A new program started in 2022, and I joined May of 2023. Right now I'm working this program. As you know, NEU is an ACI Center of Excellence for carbon neutrality of concrete and cement products. And so we'll be focusing on concrete and cement products, but we may also be focusing on some of the concrete accessories, such as concrete reinforcement, artificial intelligence, which may be used in construction in concrete industry for reducing achieving carbon neutrality. So going back to my previous slide, I mentioned that reliable method. So not only the method I should be using to validate or verify a claim, if it is plausible or it's not it's an insubstantial marketing claim, also the method I should be using to operate my validation program must be a reliable one. In a sense, is it a repeatable test method, a reliable method? Is it an international method? Can it be done in other parts of the world? So to answer that question, our validation verification program will be operated under this ISO 17029, published by the International Standardization Organization, and it's titled as Conformity Assessment, General Principles and Requirements for Validation and Verification Bodies. It's published in 2019. It's a very, very brand new document. Actually, I am also learning this document. I worked on 17065 for many years, but this is a relatively new document. And I'm not going to bore you with this figure, and I have very limited time, but I used to use this figure, show this figure during my presentations when I'm talking about conformity assessment of product certifications. And if you are a testing laboratory, if you are a certification body, you certainly know this figure. But I just want to mention that now we have a new row at the end, all the way to my right-hand side, validation verification bodies. It's new, and it's added in this figure right now. So they start discussing coming up with this standard in 2016. It was published in October 2019, and they used a prior document, ISO 14065, as reference, so they are connected to each other. But ISO 14065 was for only greenhouse gas emissions. In a sense, 17029 is an umbrella document that you can do all kind of validation verification, even including ethical statements. So it's an umbrella document for all kind of validation verification statements. We'll be using ISO 17029, but if there's a greenhouse gas emission claim validation and verification, we'll be using ISO 14065 as well. Let me describe the difference between validation and verification. I got this picture from IMIF, International Accreditation Forum website. I think it's a very good picture describing, and I cannot move this one, right? Okay. So verification is about the past activities, and validation is about the future activities. Let me give you an example. I think example will make it more sense for you. So let's assume, this is not related to carbon reduction, but just for the sake of giving an example, let's assume I have a ready-mix concrete plant, and I invented a new water filter system, which saved me 40 tons of water in the year of 2022. So that's my claim. I have a new water filter system. I saved 40 tons of water in 2022. It's certainly a big issue where I'm coming from, Southern California. We have very limited water sources. So you want to apply to the state of California for a reward or for compensation for any kind, and you want this to be verified because it's an activity that happened in the past, and I should have all the information I need, how it was measured, how did the data was collected, who did the testing, how reliable is the company doing the testing. I should have all the information to verify this claim and provide a verification statement. Now let's come to the validation, which is about future. Let's assume I am still owner of that ready-mix concrete plant, and I have this water filter. It worked for me. You know, I saved 40 tons of water. Now I'm suggesting it to another ready-mix concrete plant. I say, and I'm claiming that if you buy this water filter from me, I guarantee you'll be saving, because of your location and size, you'll be saving 60 tons of water in the year of 2025. So I'm making a future claim. Now it becomes a validation because it hasn't happened yet. And then I can validate it, but I need to ask the questions. What is this based on? How did you interpolate the data for this company? Let me get those details. But the difference, another big difference is during the verification, which happened in the past, I have all the information I should have all the information I need. I can provide an assurance for that verification statement. But for validation, hasn't happened. It's just an assumption. So I cannot provide an assurance in my statement if it is a validation report. So simplified definition, validation verification, confirmation of a claim, and claim is the information declared by client through the provisions of objective evidence. I put objective because ISO 17029 emphasizes this word objective evidence many times. You need to know where the data is coming from, who's providing the data. It has to be based on objective evidence, and the goal is to provide assurance. Assurance is in case of it's a verification activity, which happened in the past, or give confidence, for example, validation activity that will happen in the future. So I can provide those statements to interested parties, for example, a stakeholder. Remember my $5 million example? I want to invest that money. Now I have an assurance in my hand coming from NEU so that I can safely invest. What we will not be doing are, we won't be doing characterization of the material or system. We will not doing an examination or inspection, so we will not be going to coming to your factory or facility to make sure that you are producing good quality material or you are following your quality documentation. We won't be doing certification, product certification. We won't be doing conformity assessment. And the sentence below is a very good sentence. Actually, I saw it in a presentation. I liked it very much. And I can give you an example for the sentence I'm not going to read about, but let's assume I have a product. What is the predominant model building code in the United States? It's IBC, adopted by all 50 states. What is the objective of IBC? The main one is life safety through structural strengths. So if I'm showing conformance to IBC, I need to cover all the objectives. What if my main attribute, my product's best attribute is thermal efficiency? IBC doesn't give a number, like minimum number for thermal efficiency, because it's not related to public safety through structural strengths. What if mine is sound isolation? IBC doesn't even care, because it's not a part of the public safety through structural strength. It doesn't give me a number. This should be your minimum number. What about low carbon? It's not in IBC either at the moment. Actually, this was discussed during our NEU summit a month ago, whether IBC can cover the being low carbon, but it's not a part of IBC at the moment. So that's where the verification kicks in. Your conformity assessment, your product certification through a conformity assessment may miss the best part of your product. Maybe it is being low carbon. Maybe it's being, really good sound isolation. That's where you can use validation verification program to focus exclusive, to sort of show your own strength instead of completely focusing on conformity. And speeding up, 17029 requirements are very similar to other ISO standards. Impartiality and confidentiality are very top important, because impartiality is if I'm working with your alternative cement company, which you claim you have low carbon, I cannot be working with another alternative cement company, or I cannot be consulting another cement company. Confidentiality is if you are trusting me to give me your test reports, you have to know that, it's the final stop. It's where it stops. We are very confidential. We have to demonstrate it through ISO 17029. Risk management is, going back to my $5 million example, if I'm going to make that investment based on a report coming from NEU, which is an ACI Excellence Center of Excellence, now I'm a part of that decision. So risk management is also very important. I need to identify all the risks that comes with this activity. And you can submit your application, and then there will be a NEU team that will be checking your claim, and if that claim is within our scope, then we'll work with you and we'll sign a work agreement, and then we'll do an assessment. And the issue, one of the statements is if you have a claim, and if I can use an existing standard or ASTM such as ISO to verify this claim, then we can move forward quickly. But if there's a claim that there is no standard, there is no ISO standard, for example, I was talking with somebody a couple of days ago, and they claim carbon neutrality because they reduced the amount of labor required with the system. There may not be an ASTM, there may not be an ISO to verify that claim. Then we'll be forming a committee to work with this independent committee to come up with the rules, assessment rules. And that committee doesn't need to be impartial or confidential, because the committee work in a public setting. It will be open. When committee is determining the rules of the assessment, they will work with the public. And we'll be focusing on second party at the moment. And the difference between first party, second party, if you're in conformity assessment, you know very well. First party is if you are doing internally. Before you release your claim to the public, you want some internal research. That's first party. Second party, again, before you release your statement to the public, you want an independent opinion from a independent organization such as NEU. Hey, I have this claim before I go to public. can you do the validation or verification depending on the timeline? And third party is obviously, it's kind of similar to second party, but now NEU will be, it's going to be public in our website. It's going to be the report will be done for the whole public. We'll focus on second party at the moment. Report will be confidential between NEU and the client, but client may choose to release the information at their discretion. So we'll be focusing on second party. Again, we'll be working under internationally recognized standard. Anybody can apply. We won't be doing any laboratory work. We won't be doing physical testing or inspection in the NEU. When you are submitting your objective evidence, you may be required to do some testing or submit our test. And NEU is constantly seeking subject matter experts to serve on the validation teams. You can send your information to the email below. And there was so much to cover, but the time was limited, so I'm going to thank you here, and we may not even have time for questions, but I'll be around. I'll be here until the end of the session, so please find me or Sureka, our technical director, and we'll be happy to answer your questions. Thank you.
Thank you, Mahmoud. Again, I'm sure you have questions. You can, if you have time, we can ask later, or please find us and send our way. We will try to address that. Okay, our next speaker is Dr. Mary Christensen. Mary is an associate professor in Department of Civil Engineering and director of graduate studies in applied material science at University of Minnesota Duluth. Dr. Christensen's research focuses on the development and characterization of alternative cements. You already know, some of you, those are non-Portland cements, and traditional and alternative supplementary cementitious materials with the goal of improving the sustainability and resiliency in concrete. Dr. Christensen is an active member of the American Concrete Institute for a long time, as far as I know. She's currently the founding chair of Committee 242 Alternative Cements. She also part of 232 Fly Ash in Concrete and 240 Natural Porcelains. Let me get her presentation ready quickly. All right, Mary is going to talk about carbon neutral concrete materials and technologies 2023, what to implement now and what is coming. Thanks, Mary.
Thanks, Rika. Can you guys hear me okay? All right. Thanks for coming. Good to see you. Wednesday afternoon, kind of a rough time, but cool to see people. All right, so concrete, right? Compared to other building materials, other construction materials, if you look at embodied carbon on the y-axis here, embodied energy on the x, so how much it took to make it, you know, carbon and cement are pretty, concrete and cement are pretty low relative to some of these other materials. And so I think a lot of people are often confused by that. You see that and you say, oh, maybe it's not so bad. And of course, we all are here for concrete, right? So pro concrete, but, you know, it's kind of interesting to look at that. But when you consider that we're producing lots and lots and lots of concrete annually, then the carbon issue becomes big, right? And this is global Portland cement production from the 70s through more recently. You can see it's increasing, bouncing around a little bit, but it's really high, right? Over 4 billion short tons of Portland cement, and this is just cement, making up 12% of concrete maybe. So that's a lot of concrete, right, that we're continuing to produce. So the carbon footprint, you know, you hear between 5 and 8% global anthropogenic CO2, and that's an issue. If you look at specifically what the materials are in concrete that are causing this high carbon footprint, Portland cement, of course, is one of the highest ones, right? Compared to some of the other metakaolin slags, silica fume, etc. The aggregates, air and trainers, some of the other admixtures can be a little bit high, but Portland cement is largely the biggest target that we should be going after. So one of the questions you kind of have to ask yourself if you're trying to look at Portland cement and trying to reduce that carbon footprint is, where does the carbon footprint come from, right? Specifically, in the production of Portland cement, I think probably most of us know what this kind of situation is here. You see my mouse? Oh. All right. Anyway, so typical cement kiln, right? And we have raw materials coming in on the left, namely limestone or some form of calcium carbonate, shale, clay, various other materials. Now the kiln is kind of at an angle, rotates real slow, and there's a huge flame at the bottom, right? So as the materials go through, they start to heat up. You lose the water, eventually the limestone hits a certain temperature, and you start to lose the CO2 from the limestone, right? So that's just sort of a natural chemical reaction that happens when you heat limestone, right? But it contributes a significant amount to the total carbon footprint. In addition, those materials inside that kiln need to get to roughly 1,450 degrees C, which is very hot. So we're burning a lot of fuel in order to keep that flame at the temperature it needs to be. So those are kind of the two primary producers of CO2, or the two primary activities, I guess, that, let's say, that are responsible for that carbon footprint. So, Sharika mentioned earlier, there's all sorts of people on the case, right? We have ACI, PCA, all the letters, right, are working on this, which is good. And if you go online, which I have been, I'm working on this document, I'll talk about it in a few minutes. There's all sorts of roadmaps. Very cool, and a lot of them are generally heading in the same direction. So this is PCA's, the 5 C's, right? So start at the beginning, reduce clinker, reduce cement, reduce concrete, have more efficient construction, and then you get to carbonation. So pretty basic. This is GCCA. I think Sharika actually had it. We should have coordinated. I'm sorry. She had it in bullet points. Here it is, the graphic. But looking at sort of what do we do, right? And it's kind of interesting to look at this. I mean, I think there's. Looking at you can see that. Okay, yeah. Savings in clinker production, right? So looking at the plant, what can we do there? Efficiency in concrete production. Optimize mix design, optimize your aggregates, right? And those are like 10 and 11%. In the salmon, I don't know what color that is. Portland cement, right, substitution. So now we're looking at alternative cements, alternative SCMs. They're saying that's 9%. That's pretty interesting. Decarbonization of electricity, whoops. And then recarbonation just naturally from the concrete. And then they have a huge area here for CCUS. I mean, that's interesting, I think. And then efficient design and construction. So it's interesting to see sort of what everyone is looking at moving forward. This is from the California-Nevada Cement Association. I really like how they organized it. This came out in just this year. So they're looking at these emissions in 3 different categories. So the first, process emissions, saying, okay, that's sort of like the limestone calcination, right? What can we do? They're saying blended cements, CCUs, alternative cements, and clinkers. And then they break it apart into combustion emissions, saying, okay, at the plant, right, what can we do? We can burn different fuels to reduce that carbon footprint. And then further looking at waste heat recovery, renewable electricity in terms of reducing that. So I kind of like how they organize that. But it's interesting to see, looking at kind of near-term versus long-term versus mid-term solutions, kind of what's here now, what's coming. All right. So as, anybody that's here that's been working on the sustainability, resiliency of concrete over however long, it kind of always starts with sustainability and resiliency. And I teach a class on sustainability, and we spend a whole hour talking and saying, what is that? What is sustainability? What is resiliency? It's like they're really big concepts, right? Well, finally, or not finally, but we're narrowing it down, right? And then like Sharika said, we have to measure things, right? We have to get numbers. And so we're relying on LCAs now. We're relying on EPDs to give us some numbers so that we can make decisions based on data. And that's a really big deal. All of this is leading to the low carbon concrete code. I almost started asking questions to you like I was in class. Sorry, that would be weird. Call on people. Anyway, coming to this code, right? So there's a lot happening right now. It's very exciting. So I'm going to talk a little bit about just sort of the materials that are out there right now, what's maybe coming down the pike, and then what are some of the questions that we need to be asking as we start to embrace these new materials. So this is sort of how it used to look, right? How can we reduce the carbon footprint of concrete, replace some of the PC, replace all of the PC? Now we're saying, okay, we can also recapture some of the CO2, right, through CCUS. We're expanding it even more. How about we make ASTM C150 Portland cement, but in a different way, right? This little chart could just keep going on and on and on. There's all sorts of new stuff coming out. It's pretty cool. So SCMs. So probably you're like, oh great, SCMs again. Yeah, everybody knows. But the thing is, they're here now. We know how to use them. They work pretty good. It's a pretty direct, let's get rid of the certain amount of PC, put in something else, right? Lots of different SCMs. ASCMs are alternative SCMs, so there's the classic sort of traditional ones out there, and then there's a lot of other ones being developed. There's a lot of test methods being developed so that we can use additional SCMs moving forward. That's a big deal. As most of you, I have no idea what this audience is. Probably some of you know, right? When you're looking at SCMs, they're not all the same. They're different. You have to know what they are made of, right, chemically. You have to know what the particle size is, where is it available geographically, and they behave differently, right? So SCMs that are higher in calcium tend to be hydraulic. Class C ash, slag cement are good examples of those. If you add water to it, it gets hard on its own, right? You're going to have a little bit higher replacement level with those. Also, pozzolanic, right? Many of these materials are pozzolanic. They're rich in silica or alumina, right, to form, reacting with calcium hydroxide from hydration to form more CSH. And then, I don't want to argue with anyone. Is this a filler? I don't know. This is what I put on my slide, but, right, limestone is out there too, as a big one, right? We know, hearing a lot about limestone, but used to be sort of a filler grinding aid. Right now we're saying, man, it does some things to the concrete. What is it doing? How does it work? Maybe it's nucleation sites. But it's a material that's going out there replacing some of the Portland cement. When we're looking at these SCMs, and these are sort of the classic or the ones that have been around, we're looking at composition. That's really big, right? Calcium, alumina, silica, where does it land relative to others? And then we can kind of get an idea of how it's going to be. So fly ash, right? Ash that goes up into the air from coal-fired power plants. Of course, it's the big one, right? Most people's favorite, I would say. And it's really great, right? So this fly ash is a good example of kind of how complicated it is when you look at these alternative materials or newer low-carbon materials. So fly ash, at first glance, you say, okay, I'll replace 20% Portland cement with fly ash. Great. But fly ash particles are super spherical, right? They have this ball-bearing effect, allow you to maybe make your mix with a little bit less water. Okay, so now you have a more dense mix. You have a more impermeable mix. Now you have a more durable mix, right? How do you quantify that? Maybe that mix is going to last longer than the other mix, right? Need less maintenance. So there's more to it, I think, than just looking at direct replacement, right? And that's something to think about. I think we all are aware, right, that fly ash availability is changing. Coal-fired power plants are being shut down, and that's, good for the environment, maybe not so good for the concrete industry, but it's pushing us to look at other materials, right? There are a lot of other materials out there. Also, lots of harvested ash, right? So I think we've been using concrete since the 70s, or concrete, fly ash since the 70s, right? Before that, they throw it away. Since the 70s, start to use it, but they were still kind of, I'll take the good stuff and throw the bad stuff away. High carbon, high alkali, whatever, right? And now they're like, where did we put that? Right? Go get it. And so there's a lot of harvested ash out there, and really great work that's being done processing that and making it successful. So that's a pretty big one. Slag cement, of course, is out there. Works great. Not available everywhere, right? It's sort of available where you're doing steel or iron work. Sorry, should know iron from Iron Range. But it's not available everywhere, right? So sort of where you are matters, right? So if you're wanting to use slag but you're not near slag, to transport slag is going to really cut into your any kind of reduction. Silica fume is another big one, right? Kind of similar to, I would say, fly ash, right? Made from the ferrosilicon industry, tiny, tiny little particles, spherical. I think I've read twice as fine as cigarette smoke. Does amazing things in concrete, right? Tiny little particles relative to massive cement particles. You get this really great packing. You get really dense, nice bond between aggregates and paste, etc. So you get really, really good concrete from using silica fume. Ground glass pozzolan is sort of one of the newer classic SCMs. ASTM came out in 2020, and a lot of work has been done on glass pozzolan. So one of the things about ground glass is it's available. We're all drinking beverages, eating pickles, right, everywhere we are, and so there's glass all over the place. So it's not being produced everywhere, ground glass pozzolan, but there's the potential for maybe that to be more regional. Natural pozzolan, obviously this is not the United States, but you know, around the world, folks are using all sorts of natural pozzolans, volcanic ash, pumice, scoria, mostly in the West here in the United States, but materials that can be taken from the earth, maybe heated a little bit, and used as the SCMs. And then we have some, I would say, ASCMs, alternative SCMs, so red mud from aluminum ore mining, some rice husk ash, right? All sorts of other materials that are out there that are being considered. And a lot of this has to do with where are you, what's available. So you've probably seen this. Karen Scrivener put this out. Actually, I gave a talk on glass pozzolans a few years ago, and then she came up and gave a talk and showed this. And then she's like, I don't even see glass on here. And I was like, fair. But anyway, availability, right? Huge. So you look at these materials and you say, okay, they're great, but there's not a lot of them out there, right? So a lot of folks are saying, Karen included, saying, what about calcined clay? What about limestone? These are the materials that are out there abundantly around the whole world, right? And so she's been working on developing LC3 cements. So based on some clinker, right, or some Portland cement, essentially. You can't see my mouse, right? Yeah. Okay. So on the left, Portland cement, right, and then she's saying let's put in some limestone and calcined clay to replace that, either at a 50% or a 35% replacement level. So on the right here, you can see putting in the limestone. There's no CO2 emitted. Putting in the calcined clay. Does need to be heated, but not as hot as Portland cement, right? And so you have a lot less emissions, and so that's really taking off. Blended cements, of course, all different types, right? Blending Portland with slag, pozzolan, limestone, or ternary blends, which are sort of DIY, your own mix. I think we all know type 1L is really is here, right? It's here. Here are all sorts of things. I'll just leave it at that. Here are all sorts of things, right? But that reduces some of the Portland cement right off the bat, okay? And it's been around for longer in like Europe, right, than here. And so every time something new comes on board, always growing pains, always sort of a learning curve. Ultra high performance concrete is a big one right now. So if you're not familiar, it's very strong, very durable, very impermeable. Can get as high as like 32 KSI. Made based on particle packing, so there's no coarse aggregate at all. It's all fines, just packed really, really tight, right? Really low water cement ratio. And you can see in the picture on the left here, it behaves a lot differently than normal concrete. UHPC, you're probably thinking in your head, yeah, but you put a lot of cement in it. Okay, fair, you do. You put a lot of more cement in it than normal concrete. But it allows for very efficient design, right? So on the right, you can see on the left, on the right, UHPC versus some of the other more traditional structural engineering options. A lot more efficient for the same like load or same span, right? A lot lighter, okay? Lighter means lower transportation costs, means smaller cranes, means larger clearances, right? Smaller, shallower sections, etc. So you can get a lot of efficiency that way. So when we start looking at, you know, all these materials, there's a lot to consider. All right. Alternative cements, like I said, we replace some of the cement, or we replace all of the cement. I won't read this, but this is from 242, the Committee on Alternative Cements, essentially saying that an alternative cement is a complete replacement of Portland cement, except if you need a little bit of Portland cement. But okay, so it's a full replacement. We classified the. Have I been talking for 18 minutes? That's what it says. I'm a little bit okay. Clinkered alternative, calcined and non-clinkered. So in the ITG that was before 242, that doesn't matter, but we looked at trying to classify all of these different alternative cements. So there's a very wide variety of chemistries out there, which is awesome, but also complicated. You can't just say, do this for Portland and do this for alternative cements. They're all different, right? They all need to be handled differently. Calcium aluminate cements, I won't go through this whole thing here, but, oops. Our hydraulic cements typically have a lower carbon footprint than Portland cement. Applications include refractory concrete, rapid repair material. Okay, so that's the other thing to consider, is that there's a lot of alternative cements out there. It doesn't mean that they're all direct replacements for Portland cement. Okay, so Portland cement can be used in a number of applications, as you know. Calcium aluminate cements, maybe not a direct replacement. Just an example, though, there was rapid repair of an airport runway in a cold climate in Norway. They had about 15 minutes for set time and got 5,800 psi after 6 hours. So some of these cements, while they don't replace Portland directly, have really amazing properties. I'm going to go through these sorry. CSA, calcium sulfoaluminate cement, a big one. There's a bunch of magnesium-based cements. Alkali-activated cement's the one that we hear about frequently. This is probably the closest one that can replace Portland cement or be used in many of the same applications. This is a case study from Australia. They did a whole airport pretty much. They did pavements, bridge, curb, the pad. They did it all out of alkali-activated concrete. They're doing a lot of work. I think they just came out with a standard for alkali-activated cements in Doug's nodding in Australia. So they're moving really good on that over there. Just FYI, in case you're interested in these materials, ITG 10 came out with a report on alternative cements. There's also a practitioner's guide. The report has more, I would say, academic information. The practitioner's guide has case studies much more clearly presented than I gave, but some case studies kind of on these different materials. It offers a little bit of a review from the report, and then it also offers like a section on what do I need to consider if I'm looking at an alternative cement, right? Because there's a lot of questions that need to be asked. In addition, we just came out with an alkali-activated cements report, if you want more information on that specifically. So, carbon capture, utilization, and storage, right? We saw that was a key player in many of the roadmaps that we've seen. So, this is just from Wikipedia here. I've talked to Sarika and several other people about trying to make sure we're all on the same page, I guess, in terms of what's what. But essentially, there's a lot of companies out there right now looking at trying to pull CO2 either from a specific industry, such as the cement industry, right, directly from there, either storing it or using it somewhere, or capturing CO2 from the atmosphere, right? And the utilization goes a long way. Carbon curing, right, for mineralization, that could be with cements based on wollastonite or other calcium silicates. SCMs, some of the SCMs are ground with CO2, and some of the aggregates, the same thing. And so that is a very, very hot topic right now. I don't know if any of you guys got to the session, I think on Monday, but there's a lot of work being done out there on that. So some of the challenges as we look at these new materials, of course, testing requirements. Portland cement ASTMs written for Portland cement do not maybe always exactly apply to some of these newer materials, right? The example is alkali activated cements might need a little bit of heat cure, okay? ASTM's C109 doesn't allow for that, okay? Otherwise it works. So, and I think ASTM just fixed that, but there's lots of questions out there, and so it's lots of things to consider. Long-term testing data, right, is one of the things that a lot of people are looking for. I think when you're looking at any kind of construction having to do with life safety, of course you're saying, where's the data, where's the proof that this is lasting a long time? All sorts of cement properties need to be understood, right, with these new materials. There's a list here. Concrete properties as well. Lots of questions to ask, okay? But I think that the companies that are out there, you know, are learning a lot from things like ACI and starting to answer all these questions. So one of the things I've been working on, I've been doing a little bit of consulting with the NEU, and one of the things I've been working on is a low carbon concrete materials company survey. So trying to reach out to all the companies out there. And if you're a company and I haven't reached out to you, please reach out to me. Be happy to have you be part of it. But we're trying to say, you know, what's going on out there? What are the companies doing? And so these are some of the questions that we're sort of asking. So what's the technical readiness level? Are you starting up? Are you in lab doing stuff? Are you actually producing? When are you going to be available? Where are you available? What are you making, right? An alternative cement, a reinforcement, what other materials? What's your potential application? What's your global warming potential? Have you done an EPD? And then what's the cost, you know, roughly? And it's been really interesting to see what's coming back, and there's a lot of really awesome technology out there. So we're working on that survey. There's two parts. Part A is pretty quick, and then Part B is a little bit more in depth, just to kind of get a better idea of what you know you're up to. So again, if you haven't already and are part of a company that's creating low carbon materials, please do reach out, because we'd like to try to capture that for NEU to kind of move on with its mission and vision. I'm also working on a strategic concrete materials guide that's coming very soon, and I hope to include all of this, and then also to include some more details on some of these newer technologies in a generic way, as well as water aggregates, reinforcement, etc. So I am really, thanks for coming, and I hope that, I don't know, it's cool you're here. I don't know a lot about all these new technologies. It's very exciting to learn. If anybody has ones they'd like to share with me, please do reach out. I'm sure you can look me up somehow, but thanks for coming. Does anybody have any questions? I bet you do, but that's okay. Thank you.
Yeah, if you have any questions, you can use that microphone and ask. We have about 3 minutes. If not, if you have any questions, Julian has a question.
Hi, I'm Julius from Meta. Thank you for the presentation. This is addressing both the work that you just presented and also the VNV framework that you presented earlier. This is all great. How do you measure success, and how do you know it's going well?
For the technology, or what?
For the assessment framework, for example, you know, how does success look like to you? Do you intend this to be like a guide for people who are looking for solutions, or
this document? Yeah, it's supposed to just sort of give an idea of how the technology works, what the potential applications are, and then kind of an indication of maybe what's been out in the market already, and then maybe what's coming soon. So I don't know if I answered your question.
Because I think there's a lot of development being done.
Yeah.
And people want to know, like, is it available and so on. So this question you're addressing, but how do you know that what you're doing is going to be effective and bringing real impact to the practice of the industry, for example?
I hope.
And just to let you know, like, I'm new to concrete, so I'm trying to understand, like, how the community works.
Sure. Well, I mean, I think that, me and Sarika and Mahmood and, our team is trying to use our own expertise to not to recommend one thing versus the other, but to, well, I mean, it's kind of tricky, right? Because, like, I can look at
Yes.
something and say, that makes sense, and that doesn't make sense. But, and so part of what we did with the survey was to try to come up with very straightforward questions that just were like data-driven, this, or this. That being said, the survey is different than the guide. The survey is sort of internal for NEU to just use, which I have no control over. But the idea being we can try to use our sort of metrics of what's the GWP, what are the applications, what's been done, pilot projects, things like that, to kind of say this is where this technology is. And then the guide is more for here's how it works, here's what it could be used for, maybe a little bit about here's what it's been used for moving forward. So I think it's going to be a combination of the guide teaching and then the survey helping NEU to move forward with trying to help the companies to move forward, and then also to eventually get to the user.
Thank you.
Ultimately, the industry will determine that it's successful or not. We provide all the available tools, information, knowledge, everything to the public, but ultimately public response will determine whether it's successful or not. And maybe there will be times that you should be presenting case studies that are widely used. That should show success.
Got it. Thank you.
I agree. I think case studies and pilot projects are going to play a big role. Doug?
Thanks, Mary. One of the things I didn't see on your question, or maybe I just missed it, was where are they on the scalability of their product?
Oh yeah, no,
Are they at the 5-gallon bucket lab
Right.
bench basis? Have they got a pilot plant? What's the realistic timeline to bring it to a quantity that can be used in a market? I mean, you make 5,000 tons a year. It's enough for one ready mix plant. That's not scalable. That's tiny. So where are they in this thing, and where do they see that they can scale up to? Should be part of that question.
Oh yeah, it totally is. I didn't write a very good comprehensive list, but yeah, we've asked all of those questions. Where is it available specifically? How much are you producing? What do you expect in 5 years? All right, take one more, yeah.
Yeah. Hi, my name is Luca Montanari. I work with Arab. I'm currently working on the sustainability part of the high-speed rail in California. And part of our goal is going to evaluate some of the suppliers and the future mixes that are going to be used for the construction. And I wanted to check with you and ask you how transparent all these new companies are in terms of data and in terms of information. Because, part of my work is going to be to evaluate the risk against, the investment in one technology or the other. So I wanted to hear from you your experience.
Yeah, good question. I think that EPDs are becoming more and more common, and more, I think they're going to be kind of required at some point, right? If you look at the new low concrete carbon code, you're going to have to start getting a GWP for your mix, right? And you need the EPDs to do that. So I think that it's in their best interest to be transparent to you. So I would guess that moving forward, if you ask for those things, that's going to be what drives more transparency. But I think that a lot of the companies that want to do that work are going to be already having EPDs. So
That's actually one purpose of validation and verification program. Because people want assurance, are they transparent? Are they telling the truthfulness of their That's where the validation verification program will kick in and provide promise on assurance to the public.
Okay, thank you.
thanks.
Thanks, Mary, again. If you have more questions, please send our way. We can direct them to Mary and answer within ourselves. Again, the guide is the simple way to make the difference is it's general information anybody can use for basic understanding. She mentioned about case studies. If you have any case studies, please reach out to us. And that's something we more than happy to house in our website. Okay, but if you can show carbon reductions, of course. All right, let's move to our third presentation. All right, our next speaker is Professor Doug Hooden. Professor Hooden is a Professor Emeritus and the NSERC CAC Industrial Research Chair in Concrete Durability and Sustainability at the University of Toronto. He is also Principal at Concrete Durability Associates, Inc. His research involves finding ways to reduce the greenhouse gas emissions associated with concrete infrastructure. He investigates the use of materials such as supplementary cementitious materials and ground limestone and more efficient mix design to produce a stronger and more durable concrete product. His research has informed the specifications and codes associated with the American Concrete Institute, the Canadian Standards Association, and STM standards, where he chairs ACI C201 on durability, C130A on sustainable materials, STM C01 on cements, and CSA A23.1 on concrete. So welcome, Professor Hooden. Thank you for joining us.
Thanks, Sarika. Good afternoon. And I threw Larry Sutter on here, not to throw him under the bus, but up on the screen, because he and I have been working together on a lot of these changes at ASTM, both in the C1 and C9 side of those standards changes. Okay, so I said that. So there's a standard path forward, and we want to know how we want to use less clinker and cement. The message has been there. Less cement and concrete, less concrete in construction to make changes in global warming. But how does ASTM help us get there? Or are we an impediment, or can we help with that cause? So we can replace clinker with content of cement using blended cements according to the ASTM standards, and we can use less cementitious materials. Optimize aggregate gradations are something that is not done very well in North America for the most part. It's allowed in C94 concrete spec, but not many companies take advantage of it except for the pavers. And we can optimize designs and use new mixtures. And as Mary talked about, there's new alternative SCMs on the market are coming out or being developed, and alternative cementitious materials. And there's specification development taking place, but there's a lot more to do. We're getting a lot more companies, such as these new development companies. At the last ASTM meeting in June in Denver, we had at least 6 startup companies show up saying, how can we get into the ASTM process? But some of them are producing alternative cement, some are producing supplementary cementitious materials, some of them maybe both. And so we're working on a strategy at ASTM to see how we can help get these people started in the ASTM process of getting specifications and move forward. But first, what is a spec? A specification is part of a contract. It's a legal document. It's a purchaser agreement between the supplier and the purchaser of that product. And for materials, the basis, as I said, is a purchase agreement. And for construction, so typically specifications are part of a contract document for allowed construction. They're not specifications. They're not textbooks or research reports. They're a contract document for purchase. And you can't limit a property unless it can be measured. So we talk about performance and prescription. And one of the things we're doing is trying to move towards more performance-based specifications for materials. And that's why I've got this slide up there. Traditionally, a lot of the specifications have been prescriptive. So it has to be these materials and these proportions, as opposed to what are you trying to get out of the product? What are your performance parameters? Now, often they're a mix. If you look at ASTM C150, there's setting time requirements, strength requirements, but there's also compositional limits, for example. And it implies that all materials that meet those minimum limits in the standard are the same when they're prescriptive. So if we don't put the compositional limits in and we just specify performance, we can open up the doors a bit. We have a performance specification for hydraulic cements, C1157. It's been there since 1992. I think there's less than 5 states that have adopted it in the last 30 years. Because for some reason, people like to talk about performance, but they don't trust performance. Or they want to be the cooks in the kitchen, tell you how to make it as well. But as we move, just remember that if people think standards development is slow, it's a consensus-based process. It's not the same as many other parts of the world where you don't have consensus processes. So you've got many people coming from different viewpoints, and they all have to come together to agree on something together. And it changes roles and responsibility performance towards the engineering team. So they have to know what performance they're looking for, and often people haven't thought that through in detail. So we can meet a lot of the 2030 goals for reduction in global warming potential by just doing things that are allowed now in the standard. Without making any changes whatsoever, we can do these things. We have Portland limestone cements with up to 15% underground limestone that offer about a 10% reduction in CO2 just by utilizing them. They were intended to be equal performance to the base clinker for the type 1-2 cement they were replacing. They're not to be equal performance to every other cement. They were supposed to be equal in performance to the cement from the same clinker from the same factory. So if you're going to buy cement, some of the issues that have been involving with Portland limestone cement, which seems to be unique to certain parts of this country and not other countries, is that people are buying multiple sources. It may not be ever, there's issues, but like in Canada, we've been using Portland limestone cements. We're at 100% now. There was never any issue with adopting them and using them. The contractors did their base homework, and everybody communicated and got that done. Anyway, so 10% reduction from that. You can increase the level of SEMs. Fly ashes and slags have been used for years, but typically at lower replacement levels. A lot of DOTs limit the maximum SEM level to amounts that don't allow you to optimize and reduce further, but you're getting a direct reduction in proportion to what you're replacing of the clinker. And optimizing aggregation, as I mentioned, if you just have a fine aggregate and a coarse aggregate, you're not optimizing your gradation. Most ready-mix plants or batch plants in North America use a fine aggregate and a coarse aggregate. The pavers often have an intermediate aggregate, which allows them to reduce their paste content, which is required for pavements. They don't get cracking and volume change, or reduces it. And in Europe and a lot of Asia, in the newer plants, they're using up to 6 different aggregate sizes and combining them to get optimized gradation, which can reduce the paste content, which will not only make more sustainable concrete, you get better quality concrete, because permeability of concrete is related to the paste fraction. The more paste you have, the higher the permeability for a given mix. And you're going to have more shrinkage and volume change because that's related to the paste fraction. So it's a low-hanging fruit that could save another 15% of the CO2 just by changing the cheapest thing in your mix, often is the aggregates. But it requires more bins at the ready-mix plants, and it requires a little more optimization work. So these are all allowed, and they're allowed in the building code. The 318 building code allows them already. They're allowed in the Canadian American specs, and they can be done simultaneously. You can easily get a 50% reduction or more in GWP just by doing things we can do now without doing anything new. For example, C595, the blended cement spec, that's where the type 1L cements ended up. There's also a type 1T, which is limestone plus an SEM, such as fly ash or slag. So it allows you to blend these materials. And as I said, C94 allows optimized aggregations. Last month, apparently, Portland limestone cement is now 54% of U.S. production of cement type. And right now, like I say, in certain Ontario, I can't speak for the whole Canada, it's 100%. All concrete contains SEMs pretty much, but like I said, some of them are restricted by prescriptive agency specifications, which are often legacy type specifications. And not many people do the aggregate optimization. So it's fairly easy. As I mentioned, this is just a cartoon from the Cement Association of Canada report. Just using a limestone cement with either a moderate amount of fly ash or slag, you can get down in the 50% reduction range. Now, Mary mentioned this earlier. What's the availability of materials? And this is something that Karen Scrivener at EPFL has been pushing, is that on a global scale, when we're trying to make an impact, fly ash and slag are relatively small availability in proportion to the Portland cement that's being produced. A lot of that Portland cement, about 50% of that is from China, the Portland cement. So, and China seems to have peaked now, but India is growing. They're probably going to double their cement production in the next decade. And Africa is rapidly developing as well. So what's available for these people if we're not going to have more coal-burning power plants, and the blast furnaces are being converted into electric arc furnaces, so the amount of that blast furnace slag will reduce in availability over time. And you can do all these things people talk, I'll talk about these other standards. They're relatively small proportions. So what's available is raw limestone and clay that can be calcined. It doesn't have to be high quality clay, just can be calcined and blended together, and you can replace, as Mary showed, 50% of the cement, and this is the same graphic she showed, 50% less clinker, about 40% less CO2, just using a different pozzolan. A calcined clay is already allowed. It's already been used in concrete in North America, but typically the high purity metacolins. Now there's companies making these lower grade. I think Ash Grove has a plant now in Nebraska, and I understand that Holcim is doing that in Utah now, calcining clays. And then they can blend that with the limestone cement and make a 1T cement that is allowed now under the standards on 595. And you can get similar strength performance, better resistance to ingress, and resistance to other types of degradation mechanisms. And you don't need the high purity material. You can use the stuff that the China clay people and the pharmaceutical industry clays throw away as waste, as the raw material. So where are the standards barriers with something like that? Because there's been a lot of play about LC3. Everybody's excited about it. I get calls saying, where can I get some LC3? And the point is right now you can't. But it's happening fairly quickly in various parts of the world. They seem to have good properties. The availability is good, which is why it's great, especially in the developing part of the world. India and Africa have a lot of clay materials, more clay than limestone. So there's some opportunities there. Currently the standards allow cements with up to 15% limestone that can be used together with an SEM. So you could essentially make an LC3 today under the current standards. We wouldn't have to change anything. But while a lot of the DOTs have adopted 1L cements, they haven't adopted 1T cements. They say 595 1L cements, but they don't adopt 595 blanket. Now, the 1157 performance spec, as I've mentioned, been there for the last 30 years, would allow all these things because there's no compositional requirements. You just measure performance, but people aren't speccing it. So there's some limitations there. So we need to learn how to use performance specifications. Either trust performance or we don't. And this is the 1157 scope. Performance spec covers hydraulic cements for both general and special applications. There's no restrictions on composition of the cement or its constituents. You just define what's the performance you're looking for, setting time, strength, volume, stability, those things. And you'd think people would use this, but they don't. As I said, only very few people have adopted it. People want performance, but for some reason they also want to know what's in it. But he's a chef. This guy wants more sand in his mix. And so a lot of the stuff on prescriptive is because of legacy specifications that have been developed over 100 years before the use of SEMs, just based on Portland cement, water, and aggregates. They have not considered the fact that concrete technologies moved on with SEMs and chemical admixtures of various types that can drive performance. So we're developing new tests, but some of the things people don't understand or don't want to take on. So performance specifications require performance tests. Many rely on prescriptive tests. Some are pretty old. Tests need to be practical to be in a spec because you want to do them in a reasonable time frame. And we need to correlate with field performance, as Mary mentioned, and it takes time. And we need reproducibility and accurate test methods. So, I mean, I'm playing up to the ASTM part of this story, why it takes some time to do this. And we've got to have consistent product. You can use any product in concrete as long as it doesn't change every day. It's got to be consistent. And so we need some data on consistency. So we've had some recent successes, though, and Mary mentioned harvested flash. I was involved with getting the standard changed in North America, Canada, and the U.S. on allowing harvested coal ash, because the number of coal plants has significantly reduced. but there's almost 2 billion tons of coal ash in landfills around the United States at over 500 sites. Now, some of it's pure fly ash, some of it's intermingled with bottom ash, but it can all be processed. It's exactly the same material. Now, Mary mentioned that some of it was waste, wasn't used because it was not quality. That's not the case in 90% of the cases. The stuff is, there was just no market for it at the time it was put in the landfill. They were producing more ash than there was a market for. So a lot of the stuff in the landfill is actually better quality than a lot of the existing plants are producing now, because of the environmental controls that have been put on coal-fired power plants over the last 20 years. Low NOx burners, low SOx requirements, and mercury scrubbing. So a lot of the ash in the landfills is better quality to start with. You just have to get it out of the ground and process it to reduce the moisture and de-agglomerate it. And companies have been doing that, and now the specs allow it. Since June of last year, that's been allowed. One of the issues with new materials that are coming on the market, alternative SCMs or different SCMs, is what are the reactivity? How do you tell? A lot of the specs we have, like 618 for fly ash and natural pozzolans, uses a strength activity test that, although it's okay with fly ash because we have a history of using fly ash, we sort of know what it does. I can take ground sand and make it pass the strength activity test in 618. That's not a very ringing endorsement for endorsing the reactivity, but so we developed a reactivity test as part of a RILAM committee I was involved with, and I championed this through the ASTM system to get this reactivity test, the so-called R3 tests, using isothermal calorimetry as one method and just bound water measurements as another, to evaluate whether pozzolans are actually reacting. And we have a standard for it, which we're hoping to incorporate in a performance spec for SCMs. We got the ground glass pozzolan standard in 2020, which allows municipal waste glass recycling operations to process and grind the glass and make it into a pozzolan. There's about, I think, 3 or 4 plants in the U.S. operating now, but the total capacity is still under 1 million tons, so it's not a huge quantity. And there are some issues with using it in terms of its high alkali content, in terms of ASR issues. One of the things we need is better performance tests, and something that has been developed with a number of people, and Larry Sutter got this through the system, was a foam index test. It's not a new test, but it was originally applied to evaluate loss in ignition in fly ashes, but it can be, I chair a committee on performance of cementitious systems with chemical admixtures, like looking at the whole binder, and this test can be used to evaluate whether you're going to have air entraining issues with a system of combination of your chemical admixtures and cementitious materials. And it's a quick and dirty test. You can find out whether you potentially have issues and how much extra air entrainer you might have to add to get the air content you're looking for without waiting to put it in a truck and discover you don't have the air content. So it's this test that is a predictive test. There's a brand new standard that just came out in the last couple of months, cements that's set by carbonation, to allow some of the materials that they don't hydrate, they set by carbonation. So they sequester carbon. There are a couple of companies out there, such as Solidia, that use that, use a wlastonite type of calcium silicate that you then, the CO2, it binds with CO2. It doesn't harden on its own. It hardens with the presence of CO2. And there's some other companies taking advantage of that too. There was a Carboclave up in Montreal making masonry units with waste steel slag, just basically taking steel slag, making it into masonry units and carbonating it to get it to harden. It meets all the specs. And there's a test method that goes with that that's been developed to go with that spec to evaluate how you measure the strength, whether it's going to get hard or not, and how strong it's going to get. So it's tied into that specification. So that's all happened in the last couple of months. There's a test for just came out as well this year on strength of alkali-activated cementitious systems. Again, for the cement side, basically using the same 2-inch cubes that people use for other acceptance tests, but it's been modified to allow them to test these alkali-activated systems. There's a lot of things that still need to be done. We were just talking about colloidal silica today in the hallway, sorry. We're working to develop to modify existing standard C1697, is for blended SCM. So you could take a fly ash and a slag or a different pozzolan, 2 different materials, put them together and meet it. But right now it says each one of those individual materials in your blend has to meet a standard on its own. So if you had a fly ash that didn't meet one requirement, say the fineness or loss in ignition, you couldn't use it in that standard as a blend. We're trying to change that, open it up so the final product meets the spec, not the individual ingredients. And that will open it up to more accessible use of a number of materials. We're trying to look at composite cements under 595. We're also looking at a performance spec for supplementary cementitious materials. And again, I'm trying to use this reactivity test we talked about, the foam index test, some of these things to evaluate these new materials as a performance evaluation of these new materials as opposed to saying what's in it compositionally. And well, that was the one I mentioned before about each one of the raw materials in that spec has to be ASTM compliant on its own, and that causes some restrictions on evaluating materials that could be used. And one of the issues, that would also be an issue if you're trying to make a blended limestone clay system, like what I would call an LC2, to replace 50% of your clinker with a blend of limestone and clay. Right now, that would not be allowed under this spec because limestone isn't defined as a supplementary cementitious material. And that is an impediment. We want to fix that so it would allow, because blended cements have been big in Europe and other parts of the world as single products. That's not been the history here in North America with ready-mix plants doing SCMs on this as a separate addition at the ready-mix plant or at the precast plant. And having an LC2 spec would allow them to do the same thing as LC3, but added separately at the ready-mix plant. So we need to make a change that would allow that to happen. So we're looking at that as well. As I mentioned, there's many new startup companies with new materials coming in. They're coming to the meetings because they realize they need to fit into specifications to be used, in, especially for building code applications. That the building code applications have to recognize the materials by standards that are specifications. And they may have to look at modifying existing test methods because a lot of test methods we have were designed for Portland cement concretes. You can say, well, we could do the same test, but you may have to modify the test. So we have to figure what needs to be modified to allow these materials to be tested to meet a specification. Like I said, we did that for the alkali activated system, the strength system, and the carbonation cement system. So we need to do that. Find out what these materials are, how would we have to modify it to allow them to get into the spec. And that's where we're headed. But one of the also things I'm just going to mention is these new materials have to fit into the existing infrastructure. The concrete industry, you have ready-mix plants, precast plants, you've got to be able to transport the material into a plant, put it through a mixing plant, put it into transportation units such as ready-mix trucks, and place it at a job site. So that infrastructure exists, and nobody's going to build a new infrastructure for a material that doesn't fit that bill. So it has to fit into that existing infrastructure for all that part of the system. And some of the new startups, they're great, interesting products developed by bright people, but they haven't thought that through. And that became apparent last year in the Min Road test site that Larry Sutter helped organize, where they, on I-35 south of Minneapolis, they placed test sections on the interstate. And some of the materials, one of them couldn't get out of the tote bags into the ready mix. One of them started to set up in the ready mix. One of them started to set up as they were trying to place it, so they had to rip it up with it, because these people had never tested it in practice in the field. They'd only ever done it in the lab or in small scale, so they hadn't taken it through the system, scaled it up to the applications and things that happen in the field. So we want to accommodate people, but they've got to, the people developing these products have to realize they have to fit into the existing infrastructure to be able to be used in that. So we're trying to evolve the standards as fast as we can, and we're trying to respond to needs of the community as they change. But there's always resistance to change. We never see resistance to change here, do we? And it doesn't matter. And if you have a new product and something goes wrong, everything gets blamed on the new product. I've seen it 4 or 5 times with changes in materials over my career. You always blame the new material for anything that ever went wrong. It doesn't matter what the reason is. The new material gets blamed because it's easy to point to. So we need to make changes. There's only a few of us working in this space. one of the things, I'm a recovering academic, and as is Larry, but there's very few academics show up at ASTM on our cement and concrete committees because they find it boring. It's not exciting. It's not research in the lab doing students. It's taking the process through to something that can be used commercially. And they usually lose interest after a couple of meetings because it seems pedantic and boring. But it's a basis of trade and contract agreements, so that's important if you want to see your product used. So thanks for that. We're working like beavers as fast as we can, and we welcome your participation in that process. Thank you.
Thank you, Doug. Very informative presentation. If you have any questions, I may give just one question, but we are almost on time. So maybe if you can stay until the end, then we can ask those questions. Okay. So I think it's good to move forward with our next speaker. All good.
Looks good.
All right. Steve is here. He's a ACI Distinguished Staff and Code Advocacy Engineer, has his civil engineering degree from Lehigh University. He's a registered professional engineer, fellow of ACI, American Society of Civil Engineers, and Structural Engineers Institute. Steve has an extensive history in the advancement of technology and development of codes and standards related to all aspects of concrete and masonry design and construction. Steve's engagement in sustainability began in the late 1970s and include past chair and honorary member of the Sustainable Building Industry Council, drafting committee for the International Green Council Code, and active participation in related ACI committees, ASTM International Committee E60 on Sustainability, Green Building Initiative, Green Globes Consensus Committee, and many more. Okay, so let's welcome Steve. He's going to talk about code development, overview, and opportunities.
Great. Thank you, Surekha. So good afternoon, everybody. There's the one thing you're going to get out of this is it's complex. There is no easy solution. Building codes vary from jurisdiction to jurisdiction. The jurisdiction might be a country, it could be a province, it could be a state, it could be a municipality. They're all different. I'm going to focus on the International Building Code, which is, or the International Code Council codes, because those are the most popular in the state and also the basis for codes in other countries. I just had to pick something, either the Euro codes or the ICC. So I'm most familiar with the ICC, so this is what you're going to get. So it's up to the authority having jurisdiction. How rapidly does this happen? Well, a model code is developed on a 3-year cycle. Then the jurisdictions take 3 to 6 years typically to adopt it. Some are longer, some might be quicker, but from the time that you have a reference standard introduced into a model code, it could be 9 years before it's enforced anywhere. So there is this huge time lag, which puts a lot of pressure on trying to advance things more rapidly. So in many ASTM, ACI standards, because of the complexity of the subject matter, they can take 10, 15 years to get developed. So it is a relatively slow process. The reason a lot of this is slow, though, is we need the assurances that everything's going to work right. So that's an important aspect of this. But this gives you an idea of the building code referencing ACI Standard 318. ACI Standard 318 is on a 6-year cycle. If the local jurisdiction is on a 3-year cycle, and like right now they might be looking at the adoption of the 2021, or they might be developing a 2021 building code for their jurisdiction. That would be based on a 2018 model code, which then references ACI 318.14. So that shows you the time lag that is out there. So when we're looking at the model codes, there's a model code where carbon neutrality of concrete or every other building material can fit and could fit quite well, and that is the International Green Construction Code. So this is, it's administered by the International Code Council. The technical content is actually developed using the ASHRAE process through an ASHRAE committee. It's ASHRAE 189. So this is this joint initiative. Again, the technical content is all handled at ASHRAE. ICC only focuses on the administrative content or chapter 1 of the code. What the code currently says is that you need to be reporting EPDs. It doesn't go into what level of performance needs to be required. Right now, we just don't have enough EPDs out there. So they're just trying to encourage more EPDs and allow the design professionals to make their judgment calls as to what products they select based on the available data. So it needs to be an industry-wide product declaration. A Type 3 declaration means it's verifiable and developed with an approved product category rules. So we have these environmental product declarations as well as other criteria such as, is the material regional, is it bio-based, recycled, but that's the level of extent that is covered when it comes to the material and the attributes of materials in sustainability. So we have these options. It does require third-party multi-use attribute declarations. So this information just needs to be generated and put out there. And the most important thing, as I just previously mentioned, is they're really looking at getting the reporting out there so that everybody understands what we're doing and we can get a track record of how things work. Now, the EPDs right now tend to be focused, at least for concrete, on these 7 categories. So this is what you'll see in a typical EPD for concrete if it's in the National Ready Mix Concrete Association's database. That doesn't mean these are the only things that matter. I was talking about the ASHRAE 189 standard. That's ASHRAE 189.1 for new buildings except 1 and 2 family dwellings. So, but then there's other criteria that might be required depending on the particular application. There's ASHRAE 189.3, that's for hospitals, and they're looking at some other possible considerations for what must be reported because of the potential for ionizing radiation, human toxicity, particulate matter. Those come into play if I'm dealing with a healthcare facility. So it depends on your facility and what can happen. Of these things, if it's a healthcare facility, one of the things that might come up for human toxicity related to concrete wouldn't be the concrete itself, but it could be any sealers or coatings or materials that you're putting onto the finished concrete. So the IGCC is permissive in Minnesota, statewide, and all these other places, there may be 1 or more local jurisdictions that have adopted the IGCC. So it has not been widely accepted across the U.S. So the New Building Institute, very aggressive organization trying to help get us to carbon neutrality. They brought in a code change proposal to the International Building Code. This was brought in the last cycle. The code change, you can, if you go to the ICC website, you can find it. It's S17822, but it set specific limits on the CO2 content of mixed designs based on compressive strength. So this was a proposal. It got disapproved. It was part of a huge proposal that was covering glass and steel and wood, and industry opposed it because it was viewed as somewhat oversimplifying the whole concepts, and the building code officials voted to disapprove it because they didn't want it in the general building code. They felt it belonged more in the International Green Construction Code. So there was just this general conflict of, well, we want to make something happen and we want to make it happen everywhere, and the IGCC is only adopted in a few places, so it became cumbersome, to say the least. There is also the ICC 700, which is the National Green Building Standard. This is for 1 and 2 family dwellings. There is Chapter 6 on resource efficiencies. So they do address that. They do talk about things that you can do, but they're voluntary requirements when it comes to using concrete with 1 or more SEM. But again, it's moving in the right direction. It's a slow process because of all the complexities tied to this. Marin County in California took the NBI recommendations. So in Marin County, Marin County, California, there are currently these limits for CO2 content of your concrete mix designs. Washington State, NBI made this proposal to make modifications to the building code to comply with their section 1901.8.1, and it exempts small projects, it exempts precast shotcrete. So it's viewed by some that this might be upside down. The low-hanging fruit might be low dosage Portland cements for sidewalks, driveways, foundations, footers, small projects where there's a lot of them. Just like Mary was saying before, the concrete by itself doesn't look all that bad on her graph as far as the global warming potential. It's just that there's so much of it. So why not go after the large volumes of concrete versus larger building types? So as we continue to look at this, this is pretty common as to what happens when they try to bring these specific requirements in. It tends to get backed off because of the comfort level of those writing the rules and regulations, so that it ends up being report EPDs. There's not enough EPDs out there for all the concrete. And these are just some examples of what is out there to show you the types and style. You know, sometimes it's a regulation, sometimes it's a code requirement, sometimes it's legislation. There's varying degrees of what is happening out there. The Carbon Leadership Forum says there's 230 plus entities worldwide that already have some sort of rule or regulation about carbon neutrality. So here, this is an example of stuff out of the General Assembly in Colorado, where it says to do a state project, you must have a current environmental product declaration. Again, that tends to be where we're at in most jurisdictions now. Similarly, Oregon. Then there's a database. The Oregon Ready Mix Concrete Association has a database for their producers, or a few of their producers, to help get the information out about the EPDs. So when we look at the recommendations from the federal agencies, the EPA was given the responsibility to come up with a recommendation for all the other agencies on how to measure and set limits on the carbon neutrality of building materials. So for concrete, they're saying 20% less embodied greenhouse gas emissions, or 40% less greenhouse gas emissions, or simply better than industry average. And that depends on what's available locally. So they give you these three options. If it's around, you must use it. If it's not, you fall into the next category. If not, you fall into the third category, which is just a better than industry average. So it's either the top 20%, the top 40%, or just simply better than industry average. What's industry average? Is it industry average of those who have produced EPDs? Or is it really intended to be an industry average? The NRMCA database that's out there now, there's more than 7,000 ready-mix plants. There's over 2,000 ready-mix producing companies. So the NRMCA database has 60 companies reporting data. That's less than 3% of the industry that's reporting. There's 303 plants reporting, and that's only 4.5%. So what is that industry average? We're nowhere close to having anything that can be statistically demonstrated as being an industry average. So this gives you an idea of where the things are being reported, and it tends to look a lot like the most reporting is happening where there's some sort of rule, regulation, or code requirement. Oregon, Washington State, Colorado, California, that the reporting seems to be coming around as the jurisdictions are starting to require that EPDs be reported, or go even further as far as the development of the provisions to reduce or to improve carbon neutrality. The General Services Administration, for all of their projects, basically requires the same thing that was adopted in Marin County. This is the table that's being promoted around the nation by the new building initiative. So again, the EPA set the framework and then directed both the FAA and the GSA to come up with a method of compliance. And this is all from the federal legislation, the Inflation Reduction Act. So ACI now has a newly formed committee, Low Carbon Concrete. They met for the first time at the last ACI convention. They are trying to put something together that can be referenceable in these other codes to try to move things forward. And again, it's complex. There's so much that should be dealt with or needs to be considered when we're dealing with this. Should it just be compressive strength? We get questions about that. There's cap limits already in 318 and 301, the design standard or the minimum code requirements and the specifications for structural concrete. If you have, for example, if you have a saltwater exposure where you have freeze thaw conditions, your SEMs can't go over 50%. It's just prohibited by the code right now. So other things need to happen. if we're going to take the approach of, well, what can we do to encourage carbonation to occur in the concrete once it's placed at the in situ reabsorption of CO2? Well, as the carbonation occurs, the protection for the reinforcing steel is going to diminish. So are you compromising durability of the rebar by having carbonation occurring in your concrete? There is no one simple solution, and it does get really complex, and we're trying to handle it with very simplified code provisions. So the American Society of Civil Engineers, through the Structural Engineering Institute, has a sustainability committee. They're also working on guidance documents for the structural engineers to make informed decisions. ASCE also has a standard practice for sustainable infrastructure. It's pretty benign, but ASCE 73 was just released this year. But also at ASCE, they are also creating a database of the overall impacts through life cycle assessment models of concrete, well, all buildings, but there's a fair amount of concrete buildings in their database. So we have all these venues out there. As we develop a code, trying to figure out where the code gets adopted and how it's going to get adopted and who's going to champion it becomes a challenge for the industry. This is going to take a lot of boots on the ground, working with local jurisdictions to make things happen. So there's all these venues, there's federal legislation, presidential executive orders, gubernatorial executive orders, local ordinances. Things are happening everywhere on this subject, and a lot are still under development, but it is happening. So we need to be able to move forward. It would be nice to have everything based on some sort of national standard that is properly referenced. Get the work of ACI Committee 323 integrated into and aligned with the provisions going on with all these other standards organizations. So again, there's a fair amount of work. There's a lot of interest. There's also voluntary programs. There's LEED, which is widely accepted. There's Green Globes by the Green Building Initiative. There's a fair amount of programs that are out there. There's private companies that are doing everything they can to try to make their facilities carbon neutral. And it's not just the material resources, but the operational energy and impacts as well. Our typical approach to getting ACI codes adopted and properly referenced is we have always looked primarily at the model codes or a national code. And, then we would also look at, is there opportunities with standards that are being referenced? We might also be looking at state and local codes, but you can see that all the players currently involved in sustainability and carbon neutrality issues, it's huge. It's much bigger than the resources ACI already dedicates to this. So if anybody's interested in trying to champion something as ACI develops standards that are appropriate for adoption, we do have collaboration groups where people can participate. And before I get to this actual close, because we're here at NEU, I wanted to just mention something from the September 12th edition of Forbes magazine. They identified 4 challenges that the market and government forces have with accepting sustainability and carbon neutrality. The 4th thing they listed was transitioning supply chains, making sure that they can get the stuff that is out there that will provide a benefit. The 3rd thing they said was balancing short-term profits with long-term benefits. Makes sense because Forbes. Then the second thing was aligning data and the metrics. And the number one thing was navigating greenwashing. So having something out there that prevents people from being exposed to claims that aren't accurate is something that's really important that needs to be done for all of this to work. So thank you.
Great presentation, Steve. We learn a lot.